we are starting part 2, which is the actual battery reconditioning. So different from the kind of the basics that we went through. All right. So what is the memory effect? Remember that within the vehicle, okay, normal operation of the, let's just talk about a Prius. Each time the driver accelerates and brakes, the battery charges and discharges. Okay, that means that only a small portion of the active material is cycled within the battery. Right? This causes what's known as the memory effect. Okay, the memory effect is when the shallow cycling causes the uncycled portion, right? The unused portion of the battery. Okay, it builds resistance. And remember that resistance is bad. Okay, what happens is that you get physical changes in that uncycled part, which builds grain boundaries and crystallites. So you can kind of think of in a simple way that crystals are forming on the uncycled part of the battery, and that causes you to lose capacity. Okay, it's called the memory effect because the battery remembers that lower capacity and thinks that, so remember that a typical battery is 6.5 amp hour, brand new. So after a while, the amp hour capacity might drop to, let's say, 4 amp hour. Okay, the battery then thinks that it only has 4 amp hour capacity within it. Okay, so it kind of loses the 2.5 amp hours. Do you have a question? Okay. All right. And so what is battery reconditioning? Okay, so and this is and I have data to show with this, but the theory of battery reconditioning is that if you repeatedly discharge each module to a deep discharge, okay, down to 3 volts per module, which is 0.5 volts per cell, you will gain that capacity back. Okay, the battery will then remember the rest of the amp hour capacity that it has. Part of the reconditioning process is also charging it, right? So if you discharge the battery all the way down to 3 volts, you're gonna have to charge it back up. So what we do is utilize a trickle charge, which we discussed earlier, where when you approach 80% charge, you bring the current down to 0.5 amp. Okay, and again, that trickle charge will prevent you from overcharging it, prevent it from heating and swelling. Okay, so some other modes of failure, which we'll discuss here. The memory effect is what we call a reversible failure mode. Okay, reversible means that you can fix it, right? There's a couple irreversible failure modes that you want to look out for when dealing with these modules. Okay, you can lose electrolyte due to venting. So we've kind of started looking into that a little more in actually weighing the modules using a very precise scale and making sure that we have good understanding of what the modules weigh and how much electrolyte or water they lose. And you can see here there's a vent. That's the vent. So there's it's a way that it's built in the battery in order to let excess gas out if the pressure inside the module is really, really, really high. Okay. Another irreversible failure mode is damage to the casing, damage to the battery due to swelling. So obviously, that picture that I showed of the swollen battery, that battery cannot be used. You can also have polarity reversal due to over discharge. Okay, this is kind of a crucial point. So the way that our reconditioning process works is that we bring each module down to 3 volts, okay? And each module in parallel. So each module is connected to the instrument directly. It is not connected in series. Some other reconditioning processes have the full pack connected in series, and then they drop the voltage. What can happen is if some of your cells or some of your modules are damaged or have just low capacity to begin with, the polarity can flip in order to kind of accommodate the other higher charge modules and further destroy those modules. Okay, that's the main reason why you do not want to recondition modules in series. Okay, you need a reconditioner or an instrument that can recondition your modules in parallel, each module individually. Okay. And yes, you have a question?
Yeah, can you go please to the previous slide?
Okay.
Yeah, the point battery remembers the lower capacity. Can you explain it more, please?
Right here, the battery remembers lower capacity. So
yeah.
What that means is because they call it the memory effect. Basically, remember that the battery. Let's start with a brand new battery, right? You have 6.5 amp hour capacity in it. After repeated use in the vehicle, where you're only using 10% of the battery, right? You're going back and forth between, let's say, 70 or 75% to 60, 65% for years, right? So you're constantly braking, accelerating, and just kind of going up and down. The unused portion of the battery, right? Because you're not using the full battery, you're only using that 10% of it. You are then building grain boundaries and crystallites in that unused portion. Okay. So what happens is that builds resistance in it. So you kind of lose that capacity. And I have a diagram later to kind of show that. But what we mean by the battery remembers the lower capacity is that it kind of is the other capacity, the let's say to the unused material, it kind of forgets about it because it's not used. Does that make sense? That's kind of what I mean by the battery remembers the lower capacity. That capacity is inaccessible. It can't get to it. Okay. So in order to break down those boundaries and kind of revitalize the battery, we do the reconditioning process. Okay.
Okay, thank
you. Okay. Does that answer the question? And I keep explaining. I'll explain more of it, and you can actually see this data here. So the next couple slides show what happens when the nickel metal hydride batteries are cycled at shallow depths of discharge. Okay. Remember, shallow depths means very small, 10% up and down. So in this case, okay, we're going to show the discharge curves of 21 cycles. Okay. Cycle 1 is a deep cycle. And then we will do cycles 2 and 18 that are shallow. And remember, shallow means that it's not fully discharging. Okay. It's only going a very small amount. And we'll see what that does to the battery. And then we'll do a couple deep discharges, and you can actually see how that affects and removes the memory effect. Okay, and this data is all taken from the handbook of batteries. Okay, and also have some data of our own, but we'll show kind of what this looks like first. So, okay, so cycle 1 went all the way down to 1 volt. And then we're going to do a bunch of cycles to only 1.15, okay? So this is the shallow cycles. As you can see, as you keep going on, you can see the graph move more and more to the left, right? And that's bad because it's losing capacity. Okay, so before, let's see, in cycle 2, the battery would last for 7.75 hours. Okay, but after using the battery 20 times at that shallow charge, you're only getting 0.6 hours out of it. Okay, so that's pretty low. So what can we do? So now we're going to actually do these deep discharge cycles. So cycle 19, it doesn't really do much because you can see it follows almost exactly over on top of cycle 18. But then when you start deep discharging again, cycle 20 is the blue, you can see that it's getting back and approaching the original black line, right? That's cycle number 1. So what the basis behind reconditioning is that a series of deep discharges that tapers down the charging current will recover your lost capacity. Okay, and in general, you gain back anywhere from 1.5 to 2.5 amp hour, typically. Okay, so most modules, you can go from 3.5 up to 5, 3 up to 4, 4.5, 5. Above 5 is generally pretty good for modules, but we'll discuss that a little later on. Okay, so yeah, here is the visualization of the memory effect that I wanted to show. You can kind of think of the memory effect as kind of these bubbles or boundaries that form in the battery. You can see the red arrow shows that, yeah, these are grain boundaries around the crystallized positive electrode material, and the battery can't access it. So if we try to discharge, you have here that's lost amp hour capacity, right? It's inaccessible. The battery can't access it and thinks that the capacity is only the free charge that's shown in blue over here. Okay. Note though that the voltage can still be high. All right, so if you charge a low amp hour module, right, that has the memory effect, it will reach higher voltages more quickly. Okay, so think of you putting rocks into a well, right? It'll help bring the water level higher, so the more water you add to it, it rises more quickly. Does that kind of make sense? So if these rocks weren't, or these grain boundaries weren't here, because the grain boundaries are here, if you add water, if you charge it, this level will rise more quickly than if you didn't have these here. Okay, we just cannot access it. All right, and what reconditioning does is, before here you can see that in this example, you have a 4 amp hour capacity module. Okay, and basically that 4 amp hour is everything that's not within the grain boundaries. So within the grain boundaries, we have about 2 amp hour of charge that's inaccessible. After a series of deep discharges, you then can recover that capacity. So now you're back to 6 amp hour capacity. Okay. In general, you do not need to reconditioning. Does not need to be done frequently. You don't really want to do it frequently. It should be done, experts say, maybe every couple years, once the battery kind of gets older. So we'll kind of discuss that a little later on too. So any questions on this this example here about the memory effect? Okay, and next I'll actually show you what our charge discharge plan is for reconditioning. Okay, so this is actually the current plan that we're using for our users. So for the prismatic modules, It's kind of an 8-step process, and I'll actually have the graph of it in the next slide. But what we do is the first 2 steps are basically an elimination. Okay, if your module is less than 2 amp hour, we basically test the module to make sure it can hold and discharge 2 amp hour. Because if it can't discharge 2 amp hour, or if it can't accept 2 amp hour and discharge 2 amp hour, it's probably not worth reconditioning. It's a damaged module anyway. Okay, so and I'll explain that a little further too. So basically the first 2 steps is an elimination process to remove any modules that are below 2 amp hour. Okay, it won't try to recondition them. Steps 3 to 6 here, these 4 steps, that's the actual deep discharge and charge. That's the full reconditioning process. Okay. Step 7 is our diagnostic discharge, where we not only determine the module amp hour capacity, but we then analyze the watt hour energy. We determine the resistance, and again, the way that we determine the amp hour capacity is the same way that Toyota rates their modules, the same way that they determine the amp hour capacity. And then our last step here is a charge, right? Because remember, after step 7, the batteries are fully discharged. We then charge the batteries back up to 60 to 80%, depending on what you want, and the user can change that. And the reason for that, the reason that you do not want your modules charged up to 100% is if you install that battery pack the next day into a vehicle and it's at 100%, it will overcharge the first time they drive, right? And that can damage the battery. So if they, come off your lot, accelerate a little bit, and then brake, it can charge the battery up higher and go over the 100% capacity. Okay, so that's why we leave the battery at about 60 to 80% charge. Okay, and remember that all the charging processes, you have to taper them. You have to do the trickle charge. Okay, the 0.5 amps.
Question?
Yes.
Yeah. Can you explain again the second point, please? Second step.
The elimination step. So what steps 1 and 2 do? Okay, is that you step 1, we take all the modules, okay, as they are, as you receive them, and we input 2 amp hour. We charge 2 amp hours into it. Okay, and that's basically to determine whether or not that module can hold 2 amp hours, right? In step 2, after it's charged, we then discharge 2 amp hours out. Okay, so basically you're trying to imagine you have a cup, right, and you're pouring 2 cups of water into it, but it only holds 1 cup. So when you pour that out, you're only getting 1 cup of water out of it, right, because it can only hold 1 cup. So what step 2 does is it makes sure that every module that is being reconditioned can hold 2 amp hour. Does that kind of make sense? That kind of makes sense. Okay. Yeah. Basically, steps 1 and 2 is you put in 2 amp hour, take out 2 amp hour. If that module didn't behave correctly or didn't give you back 2 amp hour, then we remove it from the process. Okay, and there's a couple reasons why we do that. The first reason is it can slow down the rest of the modules in the reconditioning process, because the way that the EVc works is each step that's happening, all of the modules do them next to each other, right? So module number 1 has to finish step 5 before module number 30 can move forward. Okay. And if you actually look, this next slide might help some. This right here is a depiction of the 8 steps. Okay. Remember that steps 1 and 2 are the elimination. So remember that you charge 2 amp hour, discharge 2 amp hour. Okay. And in this case, this module passed the test because after it discharged 2 amp hour, it was still above 6 volts. If, for example, it dropped down to here, it would have been eliminated, okay, because it would have been below 6 volts during the elimination. All right, and then you have steps 3, 4, 5, and 6, and in that case, yeah, this is the bulk of the reconditioning, right? So it brings the modules all the way down to 3 volts, and we do that twice.
I got a question.
Yes.
In the elimination period, if he had dropped below 6, does that mean the battery is completely damaged? You can't use it anymore?
Yes, I would not recommend using that battery. If after that so remember that what we do is we charge it 2 amp hour and discharge 2 amp hour, okay? So imagine you have a battery that is a good battery. Let's say it holds 5 amp hour, but it's been sitting there for a while, so it's a healthy battery. It's just empty, right? When you pour 2 amp hours into it, and when you charge 2 amp hours into it, and then try to discharge 2 amp hours, it should give you back 2 amp hours. If that module can only hold 1 amp hour, right, and you put 2 amp hours into it and it can only give you back 1, it's highly likely that module is damaged, either by, leaking electrolyte, damage to the casing, heat. I'll kind of show, there's a couple ways to determine, if there's white powdery substance at the terminals, right? There's a couple of tricks that you'll kind of get and figure out which modules are good and bad from your eyes. Okay. But
question
general,
here, sir.
Yes, go ahead.
My question is this. So you input 2 amp hours into each module as a test. Now, I know you are dealing with this with just the Prius. Is this standard for all vehicles that you are working on?
Yes. Yeah, we have an elimination process for all of the plans. So one thing too, Mark, that we can provide, and I have provided to others, our guy in New Zealand actually provided a plan without the elimination step in it, so it kind of removes that, because he has a bunch of old modules that he kind of wants to repurpose or try to recondition and kind of, you could sell those packs with like no warranty. They're pretty bad modules, but in general, we recommend the elimination because you want to kind of make the best packs you can, right? If you remove the elimination, that kind of removes another, quality control aspect to it. So we do provide plans, without the elimination. And again, all of the plans that I provide, I give it to you, but you can modify. If you learn more, the more you do it, you can modify the plans yourself, right? Say you want to add more reconditioning steps. You want to add another, one of these, and you can do that. Okay, or maybe you want to diagnose your module a little differently. You can change the currents, you can change the voltage, and I can, help you with that. But in general, yeah, we provide the elimination. But if you, don't want the elimination, we can offer that too. Okay, does that kind of answer your question?
No, the question still remains. Is this standard for all battery modules, or is this just standard that you've set for the Toyota Prius?
No, it's for all the modules have all of our reconditioning plans have the elimination process in it.
Right, I understand. I'm just concerned about the 2 amp hour standard or limit that you've put for the input in the first stage.
So you're talking about other modules that are different than 6.5 amp hour standard?
Correct. And or is this specific to the car, the battery maker, and all of that?
So yeah, that depends. It is, I would recommend, so 2 amp hour, right? So if the module can hold 6.5 amp hour, and I need the specs on some of the other battery packs too, but most of the nickel metal hydride modules that you're dealing with, also the Honda ones, they're all 6.5 amp hour. Okay, so if something is 2 amp hour, that's less than a third of the capacity. So if it does not pass that test, we will eliminate it. So basically what I'm trying to say is, yeah, this is standard for all of the batteries, the nickel metal hydride batteries. For lithium ion, it's a little more difficult. It's a little different, and we kind of discussed that in our question and answer section. So does that answer?
Okay. Yes. Thank you.
Okay, no problem. Okay, any other questions on this slide? And again, yeah, we can provide the plans without the elimination, but we recommend having the elimination process in there. Okay. So here we have kind of describing what the dangers of just, what they call refurbishing is, right? Without reconditioning, what some other, basically swapping out modules means, okay? So what they do is you take a voltmeter to your pack, okay? You can detect the low voltage module in the pack, and then you remove that module and then replace it with a high capacity module that you bought, right? A new module, we'll say. What you do when you're doing that, you're installing a 6.0 amp hour module with 27 other modules that are 5.1 amp hour, right? So that could vary. That will take your pack out of balance. Okay, having a 6.0 amp hour module with 27 other 5.1 amp hour modules is an unbalanced pack. Okay. The difference between the high and low voltage blocks will then trigger the alarm lights. So what's important to note is that you cannot diagnose a module simply by its voltage, okay? Because you don't know what the state of charge is. If you have kind of low voltage modules, or you say like 7.5, but most of them are 8 volts or 7.9 volts, that module could be a good module. It's just at a low state of charge right now, right? It's just a little, it's kind of empty, right? But it can still hold a lot in it. All right, so you cannot, the main takeaway is that you can't judge a module health based on its voltage. Obviously, if the voltage is low, if you measure the voltage of a battery and it's 4 volts, that's really bad. Most healthy modules are not below 7.5, 7.2 volts. All right. In the case, so now we're going to show what that kind of looks like in the refurbishing. So this module comes in, they see this low voltage module, okay? It actually ends up being 3 amp hour. So, which is, low compared to the rest. So what they do is remove that module out, replace it with a 6.0 amp hour module. Your pack is still unbalanced, right? Because all of these other modules are 5 amp hour and you have a 6 amp hour replacement right here. Okay. Basically what you want to do is build a battery inventory. That's the best way to use the reconditioner. That's the best way to kind of make packs. What you do not want to do is take customers' packs in, recondition it, and then put it back in their vehicle. Okay, you don't know what the state of their, they call it a core. So a core is what comes, the pack that comes in from a vehicle. You want to build an inventory. You basically want to purchase some cores before you start installing packs. And then once you install a pack into a customer's vehicle, you want to take their core and add it to your inventory. Okay, you want to keep replenishing your inventory with modules. That is the best way to kind of go about the battery pack building. Okay, and I'll kind of explain right here what battery pack building is. This is kind of the full summary of this whole webinar. Okay, so there's 3 steps. Step 1, module reconditioning, which is done by your reconditioner, right? The EVc has a specified plan, and it runs automatically, and it restores, the capacity that's lost by the modules. It removes the memory effect. Reconditioned modules are then added to your inventory, right? It could be an inventory of 100, 200, 300 modules, however many. I know some have thousands of modules that use our instrument, and some are bigger users. You then select a balanced set of modules, okay? And what you do that is you look at your inventory, you look at your amp hour capacities, and you want to select, let's say Prius, so 28. You want to select 28 modules that are within 3%, okay, in either watt hour capacity or amp hour capacity. Okay. Once you do that, you have your 28 modules. The next step is pairing those modules into blocks. Okay, and the reason for that is, remember that you want to minimize the voltage difference between the blocks. Okay, remember that when the difference between the highest and lowest block is 1 volt, okay, that's when the check engine light comes on. So the main thing that we want to do is prevent block voltage differences. All right. And basically how you do it is you just sort the voltages and then you pair the highest and lowest until like working your way into the middle. And I'll demonstrate this. And also, if you have our instrument, the software does this. We'll provide kind of a spreadsheet or software on how to control and manage your inventory. Okay, and so I'll demonstrate basically all of this in parts 3 and 4 of the webinar. So we're kind of just finished part 2 and part 1. In parts 3 and 4, it moves a little more quickly now. I kind of went through the full background and learning that you have to do, and then I'll demonstrate it and show you how to use the instrument and how to make a battery pack. All right. Next, I just want to, before we break, this is what data looks like. This is a Toyota Prius before. Okay, this is before reconditioning. You can see you have these uneven discharge profiles. So this right here is the discharge. You see the blue and the red. And then you also have high internal resistances, right? Remember that the internal resistance of a brand new module is 8 milliohm. And I'll further discuss this, but after reconditioning, you can see that for this pack, this particular 28 module pack, you have a standardized discharge profile. All of the modules have almost the same amp hour capacity. That's why they all look exactly the same. And all the internal resistances go down back to, below 10 in this case. Okay. So any questions on that?